Good day everyone. Definite integrals part 7. Let us have a look at the three sums. Integral minus 2 to 2 x squared by 1 plus 5 power x dx. Integral minus pi by 2 to pi by 2 cos x by 1 plus e power x dx. Integral minus pi to pi cos squared x by 1 plus a power x dx. The limits are of the form minus a to a in all the three sums. Immediately, which property will come to your mind? Integral minus a to a f of x dx will be twice integral 0 to a f of x dx if f is even. It will be equal to 0 if f is odd. But in these three sums or sums of this model where you have got some a power x term or an e power x term, we won't be using that property. We won't be able to use. I will tell you the reason. If you consider your f of x as e power x, it may be e power x, a power x, whatever it is. Now, if you find f of minus x, that will be e power minus x, which is 1 by e power x. So, f of minus x is neither equal to f of x nor equal to minus of f of x. So, we won't be able to classify it as an even function or an odd function. So, we won't be able to use that property if you get e power x or a power x as one of the terms in the integrand, even though the limits are of the format minus a to a. Okay. So, let me tell you what we are going to do for these sums and how we are going to integrate. Let us take the first sum. I is equal to integral minus 2 to 2 x squared by 1 plus 5 power x dx. Mark this as 1. Now I am going to use the property integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. What is the use of this property? Here, in all these sums, if you add the limit, that is a plus b, that is going to be 0. So, 0 minus x will be minus x. So, that is what we are going to do. Okay. So, now here, I will be equal to minus 2 to 2. In the place of x, I have to write a plus b is actually 0. So, 0 minus x is minus x. So, straight away, I am putting in the place of x minus x. So, I will be getting minus x the whole square by the denominator is 1 plus 5 power minus x dx. Okay, do you understand how that minus x came? A plus b minus x is, a plus b is 0. So, 0 minus x, you are getting a minus x. Okay. So, now you will get minus 2 to 2 x squared by 1 plus this 5 power minus x, I can write 1 by 5 power x, then dx. Now you take LCM for the denominator and take this 5 power x to the numerator. So what will happen now? Integral minus 2 to 2 x squared into 5 power x. Here you will get 5 power x plus 1 dx. Okay. Take LCM, take that 5 power x to the numerator. So let us mark this as 2. Now I am going to add 1 and 2. You are familiar with this because whenever we use that f of a minus x property in most of the sums, we will be adding that 1 and 2. So when you add, what happens now? You are getting a 2i here, right? The limit is minus 2 to 2. In the numerator, here you have x squared, here you have x squared into 5 power x. The denominator is same, so let us write it. You can write 1 plus x power 5 power x or 5 power x plus 1, that doesn't matter. Now, in the numerator, you will be able to take one x squared common. Okay. So, I will get now 2i is equal to integral minus 2 to 2. I will be taking 5 power x squared common. So, I will be getting 5 power x plus 1 within bracket. I will be getting an x squared out. And in the denominator also, I am getting 5 power x plus 1 dx. So, these two will get cut. In all these sums, that is what will happen. So, now actually I am getting minus 2 to 2 x squared dx. Here I am having 2i. Okay. So actually in the second sum you will be getting only cos x dx. In the third sum you will be getting only cos squared x dx. You will be either getting an algebraic function or you will be getting some trigonometric function. Okay. Now we have to use that odd function, even function property. Actually, even without using that, you will be able to solve this sum. But if you use it, the limits will become a bit simpler because you will be getting 1, 0. But without using also, it is possible. Okay. So now I am going to use that property. I definitely know x squared, that is an even function. But anyway, I will show it. F of x is x squared. F of minus x will be minus x the whole square, which is x squared, that is f of x. So it is odd function. So I will write it twice integral. Here I will get 0 to a. Okay. Then x squared dx. The 2 here and the 2 here cancelling. Right. So now I will get I is equal to x squared, you will get x cube by 3 within the limits 0 to 2. So you will get 2 cube is 8 by 3. The other one will become 0. So this is your answer. So actually the sum is simple only. But when you see the limit, the format of the limits, immediately you will think you have to apply the property, that odd function, even function, that property. But you won't be applying it first. You will be applying this. And after the simplification, you will be getting an easy algebraic function or a trigonometric function in such sums. And then you will apply that property and then you will integrate. Is it clear? So I hope surely you will be able to do the second sum and the third sum yourself, so that this model will be clear to you, so that you will not be mistaken when you see the limits. We have to use only that property, odd function, even function. Okay. Now let me teach you one standard sum, which is an important sum. I is equal to integral 0 to pi by 4 root tan x plus root cot x dx. Actually, in the NCERT textbook, you have an example sum in indefinite integrals root tan x plus root cot x. Actually, there are two methods to integrate root tan x plus root cot x. One method is, you can keep the root tan x as it is. The root cot x you can write 1 by root tan x, then take LCM, and then you will substitute root tan x as t and proceed, and you will get up the model, no, that t square plus 1 by t power 4 plus 1, like that. That has been done in the example sum. But when it comes as a definite integral, I will teach you another method which will be easier to substitute the limits. Not only that, that particular concept we will be using in some other sums also. So it's better you know that way also. So now what I am going to do is, root tan x I am going to write it as root sin x by root cos x. The root cot x can be written as root cos x by root sin x dx. Okay. Now let us take LCM. So now the LCM will be, within root you will get sin x cos x. Okay. Because root sin x into root cos x is root sin x cos x. Multiplication you can combine under one root. Now here you will get root sin x into root sin x. So you will get sin x. Here you will get cos x dx. Okay. Up to this you can do easily. Now remember, the two steps which I will explain now, they are very important. Okay. First, what you are going to do is, you are going to multiply the numerator and denominator by root 2. You are going to multiply the numerator and denominator by root 2. Okay. Multiply numerator and denominator by root 2. The numerator root 2 I will write outside. Okay. So I will write my numerator as it is. The denominator root 2 I will write within root sin x cos x dx. Okay, this is the first step you have to remember. Then the next step, okay, add and subtract 1 to the denominator term in square root. What you are going to do now? Within the square root, you are going to add and subtract 1. When I do that, you will understand why we do that. Okay. So now you will get, you are having here root 2 integral 0 to pi by 4. Here it is sin x plus cos x by here 1 minus 1 plus 2 sin x cos x dx. Okay. Now let us keep the numerator as it is. Nothing need be done now. Come to the denominator. This one you keep as it is. For the next two terms, take one minus out. If you take a minus out, you will get 1 minus 2 sin x cos x dx. Right? Now, this one I am going to write as sin squared x plus cos squared x. You know, that's a basic identity. So, now you will get root 2 0 to pi by 4 sin x plus cos x by root 1 minus. This is going to become now sin squared x plus cos squared x minus 2 sin x cos x. Okay. Then dx. What is this one in the bracket? It is like a minus b the whole square, isn't it? So we can write it as sin x minus cos x the whole square. So now it is root 2 integral 0 to pi by 4 sin x plus cos x by root 1 minus sin x minus cos x the whole square dx. So now the two steps I told you important are, one is this multiply numerator and denominator by root 2. Then add and subtract 1 to the denominator term in square root. So you get like this. Now you have to use the method of substitution. Because if you substitute sin x minus cos x as t, the numerator is going to become dt. Okay. So now let us substitute sin x minus cos x is equal to t. So sin x if you differentiate, you will get cos x. Cos x if you differentiate, you will get minus sin x, but there is already a minus. So you will get plus sin x dx. That will be equal to dt. Then what is the another point you have to remember? Change the limits. The limits given here are only for x. So we have to find the t limits. So now when x is 0, t will be sin 0 is 0, minus cos 0 is 1. So t will become minus 1. When x is equal to pi by 4, t will be equal to sin pi by 4 is 1 by root 2. Cos pi by 4 is also 1 by root 2. They will get cut. So you will get 0. So you have substituted, differentiated, and you have changed the limits. So now we will convert the I in terms of t, and then we will integrate, and then we will substitute the limits. Okay. Now I will be equal to, now the limit is minus 1 to 0, right? The root 2 is here, you write it. Numerator is dt. Denominator is root 1 minus t squared. Now it is a very simple integral. There is a straight formula for it. So you know it is root 2 into sin inverse t within the limit minus 1 to 0. Right? So now you will be getting root 2. Okay? Sin inverse 0 minus sin inverse minus 1. So root 2 sin inverse 0 is 0 minus sin inverse minus 1 is minus pi by 2. So minus into minus, that will become plus. So you will be getting root 2 pi by 2. Is the sum clear to you? This is one of the standard and important sums definitely you should know. You can use the same method for the indefinite integral sum also, or there is another method I told you, you can use that one. Okay. Now see this sum. I is equal to integral 0 to 1 cot inverse 1 minus x plus x squared dx. This is a different sum. Here we have to remember some inverse trigonometry formula and then we have to proceed. You know, cot inverse x is equal to tan inverse 1 by x. Okay. So now we can write I is equal to integral 0 to 1 tan inverse 1 by 1 minus x plus x squared dx. Let us bring some format here, some formula here. So I am going to write the denominator as 1. I will take 1 minus x out. I will get 1 minus x. Now in the numerator I have here 1. That I am going to now write using this x and 1 minus x as. I will write this 1 as x plus 1 minus x. The plus x and minus x will get cut and you will be getting the 1. Okay. Now if you see, there is a formula. You have a formula in inverse trig. That is tan inverse x plus tan inverse y. That is equal to tan inverse x plus y by 1 minus xy. You remember? Now this is like tan inverse x plus y by 1 minus x into y. So I can write this is equal to tan inverse x plus tan inverse y. In the place of x I have x. In the place of y I have 1 minus x. So I will write this as integral 0 to 1 tan inverse x dx as one integral, and this I will write as a separate integral 0 to 1 tan inverse 1 minus x dx. Right? This is my I now. Now the first term I will keep as it is, the first term. The second term, I am going to apply the property here, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx for the second integral alone. So now I will get the first integral, let me write as it is. The second integral will now become tan inverse 1 minus x dx. The 1 and minus 1 will get cut. You will get tan inverse x. You already have your tan inverse x. So you will get I is equal to 2 times integral 0 to 1 tan inverse x dx. You know, this is a straight sum, simple sum which you can integrate using integration by parts. So now the u will be the tan inverse x function and dv will be dx. So du will be 1 by 1 plus x squared dx, and if you integrate v will be equal to x. Okay. What is the formula for integration by parts? Integral u dv, that will be equal to uv minus integral v du. This will be the I. So let us write I. Then uv is x tan inverse x within the limit 0 to 1. Here you have a 2, remember. So for these two terms you should write that 2 there, don't forget it. So we can write the 2 here. Okay. Now for the second one also I will write minus 2 integral 0 to 1 v is x and it is 1 by 1 plus x squared dx. Now let me write the first term as it is. I will apply the limits for both terms simultaneously. This 2 I want to take inside, so I will get a 2x by 1 plus x squared dx. Now, if you substitute the denominator, that is 1 plus x squared as t, the 2x dx is going to become dt. So what will you get? dt by t, which is log mod t, isn't it? But I am not actually using substitution. I am going to straight away write, since I know the result. I will write first the first term as it is. For the second term it is going to be log mod 1 plus x squared within the limits 0 to 1. Okay. So now we have to just substitute the limits for both the terms. So here you have a 2. When you substitute 1, it is 1 into tan inverse 1. What is tan inverse 1? Pi by 4. So you will be getting here pi by 4. When you substitute the lower limit, 0 into anything is 0. So the lower limit vanishes. Minus. When you substitute the upper limit, log 1 plus 1, you will get log 2. When you substitute the lower limit 0, log 1 plus 0 is log 1. You know log 1 is 0. So the lower limit vanishes. So now you will be getting pi by 2 minus log 2. Is this sum clear to you? So here, this is a sum where we use the inverse trigonometry properties and later we get the integration by parts. So like this, certain sums will be a bit different and you should know how to go about it. Okay. Now you see this sum. I is equal to integral minus pi by 4 to pi by 4 x plus pi by 4 by 2 minus cos 2x dx. Here the limits are in the format minus a to a. But if I keep the numerator as it is and apply, I won't be able to fix it either as an odd function or an even function because of this part. So now I am going to first split it and then I will apply that property. So now I am going to write it as integral minus pi by 4 to pi by 4 x by 2 minus cos 2x dx. Then plus integral minus pi by 4 to pi by 4. This pi by 4 I can take outside. So 1 by 2 minus cos 2x dx. Okay. So what I have done now? I am now splitting it into two parts. Okay. So now I will write I is equal to I1 plus pi by 4 I2 and keep this as my step 1. Because I am going to try whether odd function, even function for each integral separately. Now let me consider the I1 now. I1 is integral minus pi by 4 to pi by 4 x by 2 minus cos 2x dx. So I am going to apply that property. Integral minus a to a f of x dx is equal to twice integral 0 to a f of x dx if f is even and 0 if f is odd. Okay. So now here, what is my f of x here? That is x by 2 minus cos 2x. F of minus x will be minus x by 2 minus cos minus 2x. You know cos of minus theta, that will be equal to cos theta. So you will be getting minus x by 2 minus cos 2x, which is equal to minus of f of x. If f of minus x is equal to minus of f of x, you know f is an odd function. Okay. So f is odd. Therefore, I1 is equal to 0. Keep this result as 2. So we have done I1 and that is very simple. Now let us come to I2. Now I2 is equal to integral minus pi by 4 to pi by 4 1 by 2 minus cos 2x dx. Let us check whether this is an odd function or even function. Here the f of x is 1 by 2 minus cos 2x. F of minus x will be 1 by 2 minus cos of minus 2x, which is equal to 2 minus cos 2x, because already you know cos of minus theta is cos theta. So now f of minus x is equal to f of x. So here f is even. Okay. So now we will write now I2 is equal to twice integral 0 to pi by 4 1 by 2 minus cos 2x dx. Now for cos 2x, we can apply the formula. We can apply either 2 cos squared x minus 1 or we can apply 1 minus 2 sine squared x. Okay. So I am going to apply 2 integral 0 to pi by 4 1 by 2 minus 1 minus 2 sine squared x, then dx. Okay. So now I will be getting here twice integral 0 to pi by 4 1 by 2 minus 1 will be 1, minus into minus plus 2 sine squared x dx. Now you may remember in indefinite integral I have taught you, if you have integrals of the type dx by a plus b sine squared x or a plus b cos squared x or a sine squared x plus b cos squared x in the denominator, you have to divide both the numerator and the denominator by cos squared x and then substitute tan x is equal to t. You should remember that concept now. So now we are going to divide the numerator and denominator by cos squared x. Now what will happen then? Twice integral 0 to pi by 4, that 1 by cos squared x, that will become secant squared x. Here 1 by cos squared x, that will be secant squared x. This will become 2 tan squared x dx, right? This secant squared x you can write 1 plus tan squared x. So you will be getting 2 integral 0 to pi by 4. The numerator I will keep as it is because for dt term I need a secant squared x. This is 1 plus tan squared plus this is 2. So I will get 1 plus 3 tan squared x. Is it clear up to this? Now what we have to do? We have to substitute tan x is equal to t, then differentiate, change the limits and proceed. So now we have to remember this first step and this second. I1 is 0, that is easy. So actually we will be getting pi by 4 I2. That alone we should remember. So I will just make a note here. I is equal to I1 plus pi by 4 I2. And I know I1 is equal to 0. I have kept it there. Right? So now let us proceed. Now tan x is equal to, we are going to substitute as t. So if you differentiate secant squared x dx, that is going to become dt. Now let us come to the limits now. When x is equal to 0, t will be tan 0 which is equal to 0. When x is equal to pi by 4, t will be tan pi by 4 which is 1. So we have changed the limits also. So now we will get I2 is equal to, there is a 2 outside, now it is 0 to 1. The numerator becomes dt, right? The denominator becomes 1 plus 3t squared, which I can write root 3t the whole square. Okay? So now you know it is a simple formula. So I can write this is 2 into, here a is 1. So it is 1 by a is 1 only. Tan inverse root 3t divided by root 3 because the coefficient of that t is root 3. Then within the limits 0 to 1. So the 2 by root 3 I can write like this. So when I substitute 1, I will be getting tan inverse root 3 minus tan inverse 0, that will become 0, right? So now what is tan inverse root 3? That is pi by 3. So you will get 2 by root 3 into pi by 3, or I can write 2 by 3 root 3 pi. This is the answer for this is 3, I2. So now you know I is equal to, we are going to substitute, right? I1 is 0. So straight away I will write pi by 4 into I2 is 2 pi by 3 root 3. This and this 2 times. So I will get pi into pi, I will get pi squared by 2 3s are 6 root 3. Is this sum clear to you? So here, how we have done? We have first split it into two integrals, then checked for odd function, even function. The first integral was odd, f is odd, so that became 0. Then for the second one, it was even. Then we wrote the formula for cos 2x, and then we got 1 plus some sine squared, that format. Then we divided by cos squared and we substituted tan x is equal to t. Hope this is clear to you. Thanks for watching the video. If you have any doubts in either indefinite integral or definite integral, you can write it in the comment section, or you can contact me in my WhatsApp number 98414245159. I will write it here. You can make a note. 98414245159. Anybody, you can contact me. You can just write your name and your school, and whatever doubts you have in integration, you can ask me. So now we are finishing the definite integrals or the integral calculus as a whole. Share it with your friends and classmates if you like the video. Thanks for watching once again.